will talk us about microservice architecture in energy service provision, for what I understood. And so now we can give space to him and have the speech. Thank you.
Thank you very much. So, as mentioned, I'm Manuel and coming from Fraunhofer IEE. So we are a research institute in the energy sector, and in my department we are dealing with digitalization of the energy transformation. So, and we are speaking about our first steps towards a microservice architecture for a virtual power plant. So the agenda is quite very easy, straightforward. So we are talking about why we will do that, why we go to microservice architecture, how we will do that, and what we have learned from that. So starting with the why. So first of all, we are talking about digitalization. So we mainly make applications, and one of our application builds an aggregation about of different renewable energy plants. So we directly connect to the energy power plants like wind, photovoltaics, biogas, and so on. Connect the information together, monitor the information, can control the power plants through that. So for example, shut down a wind power plant and build an abstraction over the different power plants, so we can build portfolios with them. We can see what a single power plant, what a group of power plants is over the complete portfolio we aggregate. And we build as well time series from all of the information. So as every application, we have a development team of scientists and programmers, and the development team use agile approach based on the Scrum framework. And they're programming these applications in Java because we have many frameworks talking to the different protocols of our power plants, and that made us the development easy. But if the when the application grows over the time, we need more insights from data science team and energy economics. And who of you think that the data science teams speaks Java very well? So one problem is that we have teams that don't use normally these kind of language, and if we try to use their algorithms, we heard about these problems. We might have a problem to re-implement all the things from Python, for example, to our Java. So that was one reason what we say, perhaps we can use some modules in Python instead of implementing all in Java. So our complete architecture is layered. We have currently multiple 100,000 lines of code, and we are using currently a canonical data model that comes from the beginning and was very good for connecting to the power plants and gathering the information. But for some algorithms, we get some problems with that canonical data model because it was a little bit inflexible when the application grows over the time. So I think maybe a common problem. And then when we talking about scalability, we are not talking about like Netflix talk about scalability in scale up the users who use our application because they will be a little bit like stable over time. We scale in about connecting power plants over time. And we have in Germany over 1.5 million PV power plants, as well as about 30,000 of wind power plants and so on. And so connecting much more and more power plants might be a problem in the future for the scalability of such an application when it is a monolith. Sorry. So last but not least, the regulatory environment is complex in the energy sector, and not only go through all the details, but showing one picture from the German government that shows here all the laws in the energy environment, here all the ordinances, and also here the ordinances. It's not all about the electrical energy sector, it's about the complete energy sector, but of course we are depending in our application from a lot of laws, and only the renewable energy law changes about every 4 years over the last 20 years, and we have to adapt our software according to the changes of these laws. Also, we are having restrictions from critical infrastructures, from IT security laws, and so on. So, sum up the why. We have teams with different programming language background, so perhaps it's better to implement some parts in Python. We have a canonical data model what is inflexible in some situations, in others it fits very well. So maybe DDD might be an answer for that. Scalability becomes more and more important if we go to smaller power plants, like PV power plants. So build a scalable architecture is also a requirement for the future. And fast-changing regulatoric environment means avoid components that are hard to change. So we have to change very quickly, like in perhaps every sector. So we decided migrating to a microservice architecture, but perhaps the decision is easier than to answer the next question, how? Okay, so before explaining the how directly, I would show a little bit more what we are currently using. We have a JavaFX front end, we have a Java back end, no SQL database, sometimes more than one instance, and we are talking to the power plants. And if we are looking at the deployment, we have here desktop, that is desk, desktop computer, and we are normally living in VMs, but not in Azure and Amazon. We are here at critical infrastructure, and even if someone says take everything in the cloud, some customers of us don't want to be everything in the cloud. So they partly are in their infrastructure, and only over their infrastructure they can connect to the different devices here. So we are in a little bit restricted area. And so therefore I take my next slide. Guessing when we are going to our customer and saying, hey, we need Docker, Kubernetes, API Gateway, authentication, logging server, tracing server, and so on and so on, I guess they think about what? Okay, to be fair, the IT departments in the energy sector are not that bad. They have information about all these technologies, perhaps, but they don't use that in production now in every of these energy companies. So there might be a problem to make such thing as a big bang. We cannot do everything of this in one step, so we have to go a little bit more stepwise. And that is why we are thinking about which step we want to go. So that doesn't work. So, and then we are thinking about what is our approach. Perhaps we, when we identifying the main use cases and choosing one of them to start. So what I mean with main use cases is about more or less the same what in the Eberhard Wolf in the first day says about identifying the bounded contexts. But yes, when you will identify the bounded contexts, you have to see what is your data model, your domain model, and so perhaps starting with use cases what you perhaps already have, and trying to figure out what are the main things how your user work with. And then analyzing your software according to the use cases and according to the chosen use case, and examine the supporting parts of your software. And in the next steps, extracting only the business logic to perhaps some kind of a SOA-like service, because we want to change the language. So we have to implement the re-implement the business logic, and perhaps we will change something. And so going a little smaller step, and then proceed with the migration of infrastructure layers and persistence layers, and finally taking UI considerations. And I will show how we have done that. So at a very coarse view of the software, we identified 4 main use cases by analyzing the business models of our customers and understanding what part of the business model uses our software. So we have monitoring and control. Each customer of our software that trades energy needs to monitor and control the restriction by the law. So they have to monitor and control these kind of power plants. Also, perhaps very easy to understand, but it is very important to have a good administration, to add new power plants, to delete existing ones, because the portfolio of each trader is changing every year, because they have contracts only for 1 year normally. So you have to take part of these administration things. Then you have an information provision. So if you have the information of all these power plants, then there are other companies or other partners interested in that information. So you have some kind of provision of information. And last but not least, flexibility optimization. So speaking about how can we optimize our flexible parts of the renewable energies or batteries, storages, according to gaining much more money on the market. And we want to start with a flexibility optimization to cut out of the system. So starting with a coarse view of our backend, just exemplary, not all of our components are here. And we have these kind of front ends. We have service facade. We have here optimizer and a scheduling, an aggregation layer, and disaggregation means that we can get information about one portfolio and disaggregate that for each power plant, for example, control signals. And we have here persistence layer for the databases and the interface to the power plants. And first of all, we identified the supporting parts of our software marked in yellow. And after that, we extracted the business logic in another service. And in that part, we changed also the data model for the optimizer using domain-driven design. So changing the data model and adding anti-corruption layer here at that site. And the rest, the existing parts are still in the monolith. Yes, and the very interesting point is now we can use our integration tests, our system tests, and our all tests that are going to the service facade, run that test and verify if this extraction works correctly with a new programming language. So if already is done, we can deploy that at our customers, and we can see if that works, if the Python environment works correctly together with a Java environment. And if all it works, we can go to the next step. Even take more parts of the existing monolith and include that in the new service, and introduce the persistence in the service. And now we are only using the existing service facade as a delegator, and we have some kind of an API gateway inside our monolith. That is because we have these front ends and want to connect two different services here because we want to get rid of JavaFX in the technology manner and want to shift to web front end in the next way. So that is what we have done now. And in the next step, we will also go to web front ends. And that would look like that. We will introduce an external API gateway, introduce web front ends here, and then we have a complete microservice, first microservice migrating out of the monolith. Okay, coming to the learnings. So providing continuous working software during our migration was very good for us because we get feedback from the customer, and that might be every time good if you're in an agile process. The stepwise approach helped us to make smaller changes to the infrastructure possible. And our main benefit was that we can now include the domain knowledge by using Python in our service, and that's also using DDD makes the changes in the optimization model much more easier than before. Concluding, for us, microservice seems to be a good architectural style for virtual power plants. We want to show that the stepwise migration made generally a good choice when we are implementing the new services in new programming languages, and hosting on-premise is also, or at your customer side. And our next steps want to be introducing web framework as shown. We will extend our scalability testing, and also more microservices. So thank you for your attention, and
Okay, so thank you to the speaker. It seems really interesting work. Did someone have a question for Manuel? Okay, I have one. And can you tell us more about this service facade? In the sense, it seems to me that, more precisely, if you can automatize the service facade component, it seems to me that could be a first step to the solution of migrating or automatized migration, no? In a sense. That service facade, basically, it's something that connects the monolith to the new architecture, the new microservice architecture, right?
Yeah.
So you can.
So currently, we connect our front ends with an API, with a REST API.
Okay. So the service.
So service side provides a REST API
okay.
to our front end. Also, we can provide different interfaces to third-party systems with our service facade. So all external interfaces that provide an abstraction over all these facilities here are provided by the service facade. And so we can use that, in that area as a delegation. And here, before that, we have a part of the logic of our optimizing service also here in the service facade. So.
Okay, thank you. Other questions? Okay, so thank again to the speaker.